In this section, we will be talking about k-means cluster analysis, which is the second part of the cluster analysis. Unlike hierarchical cluster analysis, k-means cluster analysis requires that the number of clusters, the value of k, is specified prior to performing the analysis. The objective is to divide the sample into a pre-specified number k of non-overlapping clusters so that each of these k clusters is as internally homogeneous as possible. In practice, we may experiment with different values of k until we obtain a desired result, or use hierarchical cluster methods to determine or to help determining the appropriate k. In addition, we may have prior knowledge or theories about the subjects under study and can determine the appropriate number of clusters based on the domain knowledge. For example, if we were to sort through a stack of books, we might group them into fiction and non-fiction categories. Or while organizing a pile of shoes, we might naturally place them into casual, athletic, or dress shoe categories. Also, most k-means algorithms follow an iterative process of assigning and reassigning observations into a pre-specified number of clusters. Once the number of clusters k is determined, the k-means algorithm usually starts by assigning observations into k clusters based on their proximity to the initial cluster centers. There are several ways to find initial cluster centers. A popular approach is to initiate the algorithm by randomly selecting k observations from the data to serve as initial cluster centers. Each remaining observation is then assigned to the nearest cluster center, forming the initial clusters. The algorithm then calculates the cluster centroids, which is the mean of the variables, and uses them as the new cluster centers. This is followed by reassigning each observation to its nearest cluster center and recalculating the cluster centroids. As we can see from the chart right now, we can randomly assign these green values as a starting number of k's, which is number 4. We said that let's get to be 4. Then look at the observations around each of these points, and we cluster them together based on the Euclidean distance into 4 different clusters. After that, we get the centroid point, which is going to be in the center of each cluster. After that, once you're getting the centroid of the cluster, reassign the observations again, because look at this observation. It looks closer to this cluster than this cluster. So after reassigning the observations, we see that this point is going to go, this observation is going to go to the other cluster, as we see from here. After that, from here, after that, we assign, or we actually calculate the centroid of the cluster, 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 and we recalculate again the distances between the centroid and the other observations, centroid and the other observations, and we make sure that we minimize these distances. So in each cluster, we have a homogeneous cluster, and the distances are the minimum. The reassignment of the observations and recalculation of the cluster centroids are repeated, as we said, with the goal of minimizing the dispersion within clusters, where dispersion is defined as the average Euclidean distances of the observations from their respective cluster centroid. The cluster assignment and centroid update steps are iteratively repeated until convergence is achieved and the cluster dispersion can no longer be improved. So we have kind of a tight clusters, because it uses only the Euclidean distance, and this is an important idea, because we only use Euclidean distance as a similarity measure. The k-means algorithm can only handle data with numerical variables. In other words, it cannot analyze categorical variables unless they are transformed to numerical variables prior to the cluster analysis. This is kind of the algorithm that we are going to follow when work with k-means cluster analysis. Specify the k-value, randomly assign k observations as cluster centers, assign each observation to its nearest cluster center, recalculate the cluster centroid or calculate them for the first time, reassign each observation to a cluster with the nearest centroid, recalculate the centroid again for each cluster, and keep repeating until you get no longer improve within cluster dispersion. Compared to the hierarchical cluster methods, the k-means clustering method is more efficient computationally, especially when dealing with large data sets. Why is that? Because the first method we talked about, the hierarchical, requires computation of distances between every single pair of the observations, while k-means clustering only requires computation of distances between each observation and the cluster centroids during each iteration. Therefore, it will be good to use a cluster or to use k-means clustering method when have large data sets instead of using hierarchical clustering technique.